Recording is rolling. It is Monday, May 4th. I just gave you guys a final exam review packet. There are 50 questions in here, and the final exam is going to have the exact same questions, just the numbers are changed a little bit. So like you'll get this Venn diagram, but a little bit different numbers. You'll get some matrices, but a little bit different number, right? But otherwise, the questions are going to be basically the same. We'll go over a Kahoot review. I've got it split up right now over 3 days. I think it's what it's going to take us. Back on Friday, you guys took your Module 11 quiz, and you do have some students that need to make it up, maybe were absent, right? Especially in my later class. My later class, there's just a ton of students out. So I'm just going to make tomorrow a makeup day. And for everybody else that's not making this up tomorrow, then you can work on your 90% high goal. Last time I checked, there was like 14% of students got this. So a ton of you guys still need to get that high goal. And then we'll pick up and do part 2 of the final exam review on Wednesday. Yeah. Here, I'll make a note and then I'll do that. Yeah. And knowledge check. Okay, yeah, I'll be able to do that later. Okay. All right, so let's flip over to Kahoot. All right, you guys are ready to go. Ready to go. You guys are taking notes here? Taking notes. What is that? You know, I speak some day. Serious. Yeah. Yeah, Lord. Are you doing it right now? Yeah, we're doing it right now. Yeah.
Oh yeah. It's bad. It's bad. I know it's bad. You're correct.
All right, so we guys got that. We got this 5. I'm gonna show you guys 2 different ways you could have solved that. One thing is you could have recognized, guys, 9 to the power of what is 81?
9 to the power of 2.
Yeah, I know 9 squared is 81. Yeah. Therefore, does x minus 3 have to be equal to 2?
No.
Okay, then you can just add 3 over. Plus 3 plus 3. Okay, and you get x is 5, which you guys just said is the answer. That's the answer. Okay. Another way you could also, yeah, here, you guys take notes if you need to take notes. Here's a different way you also could have answered it. You guys remember logarithms? Logarithms. Okay, take maybe natural log of 9 to the x minus 3 equals natural log of 81. There you go. Okay, that's better. Could do that. Okay. And then, do you guys remember by the rules of logarithms, you're allowed to take this power right here and bring this down in front. So it would be x minus 3, and then times natural log 9 equals natural log of 81. Can you do that? Okay. Divide both sides by natural log of 9, so x minus 3 is natural log of 81 over natural log of 9. Okay. Right, true. Yeah, you may have caught that. Okay. And so, yeah, let's go to that. So, natural log of 81 over natural log of 9. Okay, true. This bit right here is equal to 2.
There, aren't you?
So then add 3 over, get x is 5. Okay, so there you go. 2 different methods, same answer. I'm making a recording here, so if I'm going a tiny bit fast, then you can always go back and check this recording later. All right, so nice job. Points on the board.
Mr. Griffin, just kick the guy who has my name. Don't do that. Kick him. Kick him out of the game.
Sorry. We're just got what we got. Can of soda placed in the cooler. The temperature is given by the following function where x is the number of minutes since the can was placed in the cooler. E is the special number amount, 2.718 something. Right. So question is, what was the initial temperature of the soda? Initial temperature. Guys, what does initial mean? It means how much time has passed.
Oh.
Okay.
Oh, it's 15. It's 10. It's 5.
Initial temperature.
Oh, because it's 15 minus 10. This is 5. Yeah, I saw guys. Falling along catch out and see. Something's a bad shape.
Catch him up.
All right. So you guys got that? All right, check it out. Guys, when I say initial, that means where the x goes, I'm going to put 0 as in 0 minutes. Okay, so that means initial That's what that word means. It means no time has passed. Okay, you just put that can in the fridge. Okay, so you're gonna go e to the 0.05 times 0. Okay, because doesn't that make this whole exponent just 0? What is e to the power 0? What is anything to the power 0? 1. Yeah. Guys, watch this. E to the 0 is 1.
Whoa.
So this is all equal to 1. Okay? So the initial temperature is -10 plus 50 times 1. That's 5. And then, well, I think the attached unit was degrees Celsius. That's probably what it was. Okay. So -10 plus 15. Okay. So if you see the word initial, that means 0 time has passed. You plug in 0 for the amount of time, which in this case is x. Okay. Anything to the power 0 is 1. So e to the power 0 is 1. So that just turns into that. All right, you guys got that in your notes? Just got that. All right, got more points. More points.
Kick the guy who has my name in it. I don't know.
What?
Wait, Mr.
This
Yeah, kick him out.
Why?
Because that's not me. Kick him.
Yeah.
Wait, Mr.
What's the temperature of the soda after 15 minutes? 15 minutes.
15 minutes. I freaking here. Every night, someone so. Yeah, it's fine. It's definitely. Oh, I'm going fast. All those unique pieces what you did to me.
X is the number of minutes that have passed.
What?
15 minutes.
God, boy, did you put it.
So as long as you have a calculator within reach, I think you'll be all right.
I definitely. I know. You know it's stinking. I got it. I'm in.
All right. Hope you guys got that. Check us out. Okay. So give you time as a function of minutes, and I said, how about after 15 minutes? So where the x goes, you put 15 because x was time in minutes. Right?
Yeah.
So, okay. So let's try this out. Let's plug this in here. So I got -10. Whoops. Try it again. -10. All right, and then plus 15, and then second e to the power of. Guys, can get the e. And then -0.05 times 15. That's all in parentheses up there. Okay. As long as I plug that in correctly, it should give me the answer, shouldn't it? Okay. So -2.91. And then, yeah, I think it was degrees Celsius.
Monday through Thursday.
Like that.
That's what my first period said.
I got to do that. You guys can do that.
Yep.
And plug it in. Plug it in. Plug it in. All right. More points. More points.
People love the names.
All right, we got Forrest. Mr. Griffin is 67. Oh, got Dominique. Got Catch J. You got Nate.
Wait, that's you. Not
Yeah, probably was. Got $1,000 principal invested in an index fund is growing at 5% annually.
mispronouncing.
Right. What is the value of the fund after 20 years? 20 years.
It's
Yeah.
It's a premium.
It's right.
All right, pretty good. So, got interest growth rate And so the amount you have after some time, P is the principal. I told you it's $1,000, so you go to the bank, pop in $1,000 or put into the index fund, this investment. I told you the interest rate was 5%. Now 5%, is that like 0.05 as a decimal? Okay, I got 1 plus that. Okay, that makes this number 1.05. Okay, so every year I'm multiplying by 1.05. And I do that 20 times for 20 years. That's a power of 20, which means every year it's also compounding the accumulated interest from the previous year and so on. Right? So I put that in the calculator and I got this right here, which is what you guys got.
Jew. Don't call me a Jew. I'm not a Jew.
All right.
15.
You guys get there. You guys get there.
Nice.
Thank you, King.
Yeah. All right. Okay, more points. Which equation describes the following graph?
No, what's this, Mr.
Here.
Pittman?
I'll help you guys out. Let's do this verbally. Guys, is this some kind of a square root curve? Now, I see these all are like 2 times the square root of something. So really, this is a translation question. Guys, doesn't the square root of x start at 0, 0? This has been shifted left 1, down 4. Guys, how do you go left 1, down 4?
Plus 1 minus 4.
Which one is left 1, down 4? Left 1, down 4. Yeah, it's that one right there. Guys, here's left 1, and here's down 4. Right? And
I'm saving this one.
could you, if you wanted to, pick any coordinate and test it? For example, how about the coordinate -1, -4? Right. Guys, if I plug in -1 for x, what does this whole square root come out to? What?
Oh, I thought you meant the
Just the square root bit would be 0, right? 0 times 2 is still 0. 0 minus 4 is -4. That gives you that coordinate, doesn't it? Or, here, let's go back to the graph here. Because what about this coordinate right here? Does this look approximately 0, -2? Is that approximately 0, -2? Right, let's try that. What if I plug in 0 for x? Guess what's 0 plus 1? 1? What's the square root of 1?
Oh, coins!
Times 2? Right? And then minus 4? Yeah, that's the same coordinate. It's the same coordinate, which is right there. You can pick any coordinate on that red curve and that, yeah, that green box answer would be the answer. Alright, points. Simplify.
Come on. Don't call me that. Come on. I'm not one of those people.
That's nice, not. It's good enough. No, not, bro. Not even. You miss coin or make one color. Not coin. Guys, don't fix it or where it's circle is wrong this.
Wait, I'm watching it.
Wrong this.
It's wrong this. Wait, I'm doing my math. I'm
Bro,
calculating
8 o'clock here.
my calculation. I think it's blue or green.
Wrong this, bro.
Oh, then it's blue. Yo, it's not letting me click it. Oh, it's
I
red.
told you it was wrong.
Alright, here, plug it there. So here's what I gave you. There's a few ways to navigate this. Here's what I think is, well, I could break that 20 into 4 times 5. And x to the 3, that is an odd power, and same thing for on the y is an odd power. I know if I take a square root, I can group pairs of x's and pull those out as single x's, right? So, guys, can I rewrite x to the 3 as x squared times x? And x to the 9 is 9 to the 8 times, or y to the 9 as y to the 8 times y. It's the same thing, right? Okay. Now, guys, what's the square root of 4? 2. So I got a 2 out here. Okay. I haven't touched the 5, so, well, I'll set that up later. I still got a 5 that's stuck underneath the root. Okay, is that okay? This turns into this. Okay. Guys, what's the square root of x squared? Just x. Okay. But I still have this x stuck in here, so this x still has to stay inside the root. Is that true? Okay. Yes, what's the square root of y to the 8? Yeah, y to the 4. Okay. It's like 4 groups of y squared. Okay, so every time you see a y squared, you can take that as y. You can do that 4 times. But there's still another y stuck in here. So this is still under the root. So I think that should be the answer right there. 2 x by the 4 root 5xy. Right, that look about right.
Yeah.
Alright, let's see how you guys did. They did.
Yeah.
Oh, one winner. That's the answer. Alright, one winner.
Wait.
Okay.
Yeah.
Alright, you guys good? Got your notes?
All of it, like which one?
The coin.
Uh,
No, No.
That's all for you.
Stop for you.
It's not for you. But it's a good thing.
Oh, I know this one. Promise, I swear. Hey, what? You're not your calculator. Me? Not your calculator, buddy. Ranger. Math is math. Math is I guess.
Oh my.
Hey. I mean, I'm thinking about it.
All right, let's you guys go. Oh yeah, oh yeah. Okay. So here's what I gave you at the top. I gotta go through a series of algebra steps and unbury this u right here. First thing is add 7 over and you get 16. To get square root of something is 16. Right, now I have to square both sides. So square, square. Right, now I'm up to 256. So u minus 5 is 256. Last step is add the 5 over. And then that will give me the answer.
So much freaking more.
Right, you guys can do that. Do that.
Well, it's magical. I'm adjusted.
Aiden, you're basketball.
Oh, thank you.
Catch the G.
Rationalize the denominator and simplify.
We gotta catch them all.
Oh yeah, I see it. Yeah, I see you pee.
Young face. Aiden, that's weird.
I see you pee.
What? Oh. We can lock in, bro.
Wait, I see you pee though.
Unlock it, bro.
Okay. Choose me that.
Left up, right down. Left up, right down, left, right. Right to the left, far to the right.
I think it's red or yellow.
You just one, negative one. One. Bad. Hey, bro, what you doing over there?
Oh, it's yellow. I knew it was
Yeah, check this out. Alright, so here's what I gave you. Do you guys remember something called conjugate pair?
Yes.
And the premise said something about rationalize the denominator. So see here it says root 5 minus root 3. I'm gonna multiply by root 5 plus root 3. But I do have to also do that on top so that, guys, is this pink fraction right here very simply equal to 1? Yeah, guys, this whole pink fraction is equal to 1. Right, so I'm setting this up so that the denominator, at the end of this process, will end up having no radicals in it. There's no square roots in the denominator anymore. Okay. Right, so it always works this way. So yeah, root 5 is 5. Bing! That's that 5 there. Then I got root 5, root 3, I'll call that root 15. And this is negative root 15. So I have plus root 15 minus root 15. You guys see how all the roots are going to cancel out in the denominator? As long as you do this method, that always happens. And finally, got root 3 and root 3. Okay, and also negative in the mix. So that makes 3 and negative. So negative 3. That's where that's come from. Root 3 squared is 3. Okay. The other half of the story is on the numerator side. Root 5 is 5. Bing. We got root 15 plus root 15. Ooh, that's like 2 root 15s in the end. Bing. And then root 3 makes 3. Bing. Now this 3 and this 5 can combine. Bing. Makes that 8. And then the denominator comes out to 2.
Oh, this all makes sense, Mr. Gifford. All the math numbers. All makes sense.
Yeah. Yeah, you can do that too. Yeah. You do 4 plus root 15. That's true. Yeah, that could also work if that was an answer choice. Yeah, good call. Huh? All right, guys, good. It's good. All right.
See, question.
Area of a circle is given as pi r. Area is pi r squared. The radius after t meters is given as 11 over 2 times t. What's the area in terms of time? Right, it's a composite formula. Sorry about the weird letters. I copied those straight from Kahoot.
Yo, Z, keep your hands on my computer. You make me get stuff wrong.
It's not my fault you suck at math.
Bro, you literally clicked the answer on my screen.
Literally, I did, bro.
Grayson, bro, stop selling me.
What are we gonna catch them all, bro?
What are we
We're gonna catch them all.
I'm trying to catch them all, but you're holding you. Gosh.
We're gonna catch them all. You never wrote to domain.
Hey, Mr. Confidence is no domain.
Mr. Griffin, do you know what JJK is?
No.
I don't think he has his own
He
domain.
definitely has a domain. No, he has like
Oh yeah, he's
That's my domain, right? You're welcome. You're welcome. You're welcome. You're welcome.
All right.
We're gonna catch
See
them all.
here.
We're gonna catch them all.
Yeah. So, but what does kind of bother me about this is that they did switch out the letters. They're using different letters for the same concept. Like area here they're calling A, and down here they call it area Z. So, yeah, I took a screenshot straight from an Alex question to get this stuff. Wait, in the real life, in the real world, you might see that. You might see some variable referred to by different names. You have to recognize, hey, that's the same thing. That could be like this one. So we're doing area as a function of radius. Here's radius as a function of time. So therefore, what's the area as a function of time? And you can get that by creating a composite formula here. Okay. So I got area is, well, I know it's pi r squared, but instead of r, I'm going to write 11 over 2t because that's what r is in terms of time. Okay. So what I see is that this radius is growing bigger, bigger, bigger. And the more the time that passes, the bigger the radius. Right? And of course, that also has an effect on the area, and that's what this equation is. So put this together. What is 11 over 2 being squared, and then times this pi out here? I'm looking at 95.03. And then this t is still being squared, so that's still part of it. Okay. So that should have been the answer right there. Okay. So that's basically area as a function of time. Okay. So now you say, like, so much time has passed, you can plug that in, and you can immediately know what the area is. Okay, composite function. All right, you guys get a composite function? You just put one function in terms of the other function, right? Okay, so take this entire expression for, this is area, this is radius, and then we're back to area. Okay. So I took radius as a function of time, I plugged it in for this r, right, and now I have area as a function of time. Boom, boom.
Yeah, go. Yeah. Half the Jews on top. So
16-foot ladder leans against a wall. The base of the ladder is 7 feet from the wall. What is the vertical position of the ladder on the wall? Yeah, you said Pythagorean? Sounds about right.
Pythagorean.
Wait, so 16.
Over 20 years.
Yo, my calculator's broken.
Everybody's calculating broken, Mr. Griffin. Keep in mind.
What's
No, I don't check my answer. Listen back.
Just like catch them all.
Well, 16 squared plus 7 squared.
Hey, you do it, bro. You do it, bro. God, we don't have that.
All right, should get 14.4 feet. Let's try here. Okay, you got the same Pythagorean theorem. So you got this leg squared plus this leg squared is this hypotenuse squared. Okay. Now we're solving for one of the legs, so careful about that. A lot of students will mix this up and they'll think the 16 feet is one of the legs and they're solving for hypotenuse, but that's not what you're doing. Right? So you do have to subtract is one of your steps. You have to subtract. So I'm going to say that height squared is 16 feet squared minus 7 feet squared. So what's 16 squared minus 7 squared is 207. So y squared
Where did you go?
is 207. That's feet squared. So take the square root of that.
This?
Looking at y is 14.39. And that feet is the units feet. 14.39 feet.
Go
I'm
under.
retired.
Alright, you guys can do Pythagorean.
A squared plus B squared.
You go C squared.
That's
Yeah,
it.
jump up.
That's
Jump
it.
up the tree.
Yeah. Yeah. Logarithms.
Pythagorean.
Oh, I will give you all those log rules on the exam. You just got to know how to apply them.
Yes.
Wow. This is a magical Mr. Giffen.
Okay. Yeah. Wait, how do you? Oh, right there.
What's natural law? That's a chip.
You need a 5 plus the 1.5.
It's not a 5, it's an estimate. It's a 5. It means number.
Right. There is no base 5 on a calculator, but I'll show you guys 2 different ways how to do this.
It's natural law. You get the big numbers. Look, do it. Oh yeah.
Alright. Alright.
Natural law.
Yeah, natural log is one way to do it. That's true. Yeah. Actually, let's do that way first. Okay. So how do you do it with natural log? Natural log 125 over natural log of 5. Okay. Because your calculator only knows 2 log bases. Your calculator knows base 10, which is this key here, and base E or natural log, which is this key here. So how do you do base 5? Well, you can start from any base, and here's the base conversion. So let's do natural log 125 over natural log 5, or you could just do log base 10. You would still get the same answer, which is 3. Okay, so the answer is 3 on the nose. Okay. Again, even if I did log 125 over log 5, it still gives me 3. It still gives me 3. Okay. But another way is you could use a you guys remember the phrase roll the log? It's a way to convert logarithms into exponentials or vice versa. Because what if? Okay, I mean, here's what I gave you. Gave you this. Right. What if I very simply say equals x equals x? Okay. Can I convert this into an exponent form? Because what does this look like as an exponential? Here's your base 5 to the power of what? X. Yeah, which turns out to be 3. Yeah, it's 1%. Right. Right. Yeah. You might recognize that you say, okay, well, 5 to the power of what would be 1.5? 5 times 5 is 25, times another 5 is 125. So from that perspective also, x has to be 3. Okay, so there's 2 different ways to do it. 2 different ways. Alright, so you guys know a couple ways to solve logarithms there. That's good. Alright, next one.
Mr. Griffin, that's 6-7.
Oh yeah, 6-7.
I'm coming back, guys. Don't worry.
Ooh.
Oh my god.
A little different.
Oh, it's the other way around.
Yeah, all the way around.
How about
5-6.
5? Yeah, what was the last one? 5.
The logs on the
He's got final questions.
Yeah, guys, your final exam, it's gonna be same questions, just the numbers will be a little bit different. But otherwise, yeah, it'll look like this.
It's 9.
Give me all the answers.
Oh, because
9. Take a look here.
Not 3 times.
So here, guys, so we just say, here we go to the last one. If I take this base to the power of the opposite side, it's equal to this inside number. So 5 to the x is 125. Okay. Now I can do the same type translation right here. Guys, what to the 1 is equal to what? 3 to the 2 is equal to x. Isn't that it? Isn't that the translation we just did here? How it applies here? Okay. And this time, it's what we're looking for. That's the answer. Okay. If you ever hear the phrase roll the log in math class, referring to some version of that process.
This is anti-side wins.
Yeah, but
Of course, Aiden knows what it is.
Right. Into points. Experiment.
What?
I gotta expand my bond.
That was very good.
Yeah, it's not gay.
What if it's hard?
What do you mean what if it's not bad? Oh, that's valid.
Hey, yo!
It's
47. Just yell at it right now.
No, I need the map. I'll cheat like you. I'll cheat like you.
Yes, you do. I literally saw you cheat on that.
Oh, why are you checking the
Y, X,
Why is that?
Let me check GPT. It's in that way. I already.
Not two people I can see.
I think it's yellow.
Yeah, you're done, bro.
I'm still on the podium. Still on the podium. Okay.
All right, so check this out here. Okay, so I posted a list of logarithm rules up there. I know it's really tiny font on the screen, but you'll have that list of rules in front of you on the final exam. You just have to know how to apply the rules. So this is logarithm expansion rules. And so if I have logarithm of a giant fraction like this, anything multiplied together, I can add those as separate logarithms. Anything in the denominator like this x, I can subtract off that logarithm. So this is equal to this. Also, guys, the square root of something is that value to the 1/2 power, right? Which is also about to be helpful because this never gets to the next step. Guys, if you have log of like z to the 3, what can I do with this 3 right here? Can I bring that into print? Say 3 times
Oh yeah.
log of z? Yeah, you guys remember that? It's one of your rules.
Yes.
Now I also did that over here with this square root of y, which is y to the 1/2, and I can bring the half in front.
Thank you for spoiling.
Log x. Okay. So this should be the answer right here. Right back.
Jesus.
All right, you guys got that?
Yeah, I missed it. Wait, no. Yes, I did. I did.
Okay, combine logarithms into a single logarithm.
Pull up on your block.
1/2 natural log a plus natural log of 3b minus 5 natural log of c. So just the reverse of what we just did.
Oh, wait, it's yeah. No, mama.
2 coins. Good, you ate it.
No.
Coins.
Can't be true. That's impossible. Hey, did you press circle again?
Yes, bro. Good.
Did you press circle?
Yeah.
Aiden press circle.
All right. Well, it's one winner. Take a look here, guys. Look here. We take notes. So this is the same as the last question, just exactly in reverse. So now you're taking expanded form and you're going to consolidate it to a single logarithm. So 1/2 natural log of something, I can take that 1/2 and put it to the power, which of course ends up becoming square root. Natural log of 3b, well, you could expand this into natural log of 3 plus natural log of b, but that's the opposite of what I'm trying to get you to do. So really, this is already pretty consolidated. It just carries down as a 3b. And then minus natural log of something, I know that's eventually going to show up as a divided by. And 5 LMC, I can take this 5, put it in the power, so bring that down here. Same thing. Okay, so if you look at the last question, this consolidated form expanded, or this question, expanded form consolidated. Guys see those are just backwards of each other? Guys see that? Everybody got that in their notes? Got your notes?
You don't get
Which?
What do you got, mother?
Yeah, mug. I got mug.
You got mogged? They mogged you?
Yeah.
You guys stay back there?
Yeah.
Oh, Malaga.
Are you moggy?
Alright, here, guys, let's go over this graph. Do you guys see a vertical asymptote at about x is -3? Do you guys see that? X -3? So I think this is some basic log shape that's definitely been shifted left 3. And maybe it's been shifted around some other ways too. But it's definitely left 3. Guess which one of these says left 3? Okay, guys, that's the only one that was shifted left 3. Because doesn't natural log of x or any log of x have a vertical asymptote on the y-axis, which is at x equals 0? Guys, only one of you guys got this.
I did.
Oh, okay, great. Here. So you guys know if you see that this plus 3 inside parentheses, that means to shift the whole graph left 3, just like the picture. Are you guys good with that? Okay.
Yes.
Are you guys ready for that? All right.
I'm sorry for what I did.
All right, for the win!
I won.
I can't wait.
Expressed in terms of natural logarithms.
so fast. We just we can always be the. So we're not beating fours. We're so we're yo, y'all are beating fours, bro. I just had to click so fast. Beat fours, so I'm beat it. Oh, all it is wood. Oh wait, you have special effect. Are there something for this?
And the list of logarithm rules that would be helpful. Of course, you would have in front of you printed out, so you could refer to them.
I have the answer. It's gonna be awful.
Watch me make mistakes.
No.
One winner, one winner. You guys, everybody be taking notes. Everybody's be taking notes right here. It's here's what I gave you guys. I said express in terms of natural logarithms. Okay. If it helps, you can glance at the answer choices and kind of get an idea of where I'm going with it. So I'm going to take this 3 and put it in the power of that 10. Make it 10 to the 3. So that's a valid step, right? If I want to, I could check my step every step along the way. Well, actually, I don't have a base 5, so I can't really do that. Never mind. Okay. But right. So got that. Is that okay? And then guys, what is 10 to the power of 3? 1,000, right? And now from here to here, this makes it calculator friendly. Is I did a change of base formula. You guys remember change of base? Here, I'll spell it out. Change of base. Change of base. Okay. So I got base 5 here. Right. But the calculator only knows either base 10 or base e. So let's try the base e. So I'm going to do natural log of 1,000 over natural log of 5. If I want a decimal approximation, let's see, I wonder what this is. Natural log of 5. Right. This is approximately equal to 4.29.
I'm missing all my notes the other day.
Yeah, you guys good so far?
Yeah,
Guys good so far?
Is it good?
All right. Yeah, great notes. Those look like great notes. Yeah, you guys are keeping some good notes. Going to help you on the exam. Right. And so that is the first third of the review.
Oh,
First third. All right. Nice job, guys.